This is SpaceTime, Series 23, Episode 22. Coming up on SpaceTime. A warp in the Milky Way Galaxy. NASA's Mars 2020 rover, officially named Perseverance. And the last flight of the original SpaceX Dragon. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study suggests that a warp in the disk of our Milky Way galaxy is probably being caused by an ongoing collision with another galaxy. Data from the European Space Agency's star-mapping Gaia Space Telescope indicates the distortions being generated as the impact sends ripples through the galactic disk, a little bit like a rock being thrown into water. Since the late 1950s, astronomers have known that the Milky Way's disk, where most of its hundreds of billions of stars, including our Sun, resides, isn't totally flat, but rather curved downwards on one side and upwards on the other. For years now, scientists have been debating exactly what's causing this warp, and they've proposed numerous theories, including the influence of an intergalactic magnetic field, or the effects of the dark matter halo, the mysterious invisible matter that makes up most of the mass of the universe and surrounds galaxies, including the Milky Way. Now, if the dark matter halo had an irregular shape, its gravitational force could bend the galactic disk. But now, with its unique survey of more than 1 billion stars in our galaxy, Gaia may well be holding the key to solving this mysterious warp. Scientists studying details from the second Gaia data release have now confirmed previous hints that the warp isn't static but changes its orientation over time. Astronomers call this phenomenon precession, and it could be compared with the wobble of a spinning top as its axis rotates. In fact, the Earth does the same thing as it rotates on its axis. A report in the journal Nature Astronomy suggests the speed at which this galactic warp precesses is much faster than expected, faster than the intergalactic magnetic field, and faster than any dark matter halo would allow. And that all indicates that the warp's being caused by something else. Something more powerful, something like a collision with another galaxy. The study's lead author, Eloisa Poggio from the Turin Astrophysical Observatory, says the warp appears to be completing a complete full rotation around the galaxy every 600 to 700 million years. And that's much faster than computer simulation models looking at the effects of the non-spherical halo had predicted. Interestingly, the warp speed itself, however, is still slower than the speed at which the stars themselves are orbiting around the galactic center. The Sun, for example, completes a rotation around the galactic center every 230 million years. Our Sun and Solar System are located about 27,000 light-years out from the galactic center, in a region of the galaxy where the amplitude from the warp is very small. Measuring the warp's characteristics are possible, thanks to Gaia's unprecedented ability to both accurately determine the position of more than 1 billion stars in our local part of the Milky Way, and also to estimate their distances from Earth, providing science with a three-dimensional celestial map. Gaia also measures the velocity of stars across the sky, allowing astronomers to work backwards and determine where those stars would have been millions of years in the past and where they're likely to be millions of years into the future. And by measuring the apparent motions of millions of stars across the sky, the authors can model large-scale processes such as the motion of the warp. Scientists don't yet know exactly which galaxy could be causing the ripple, or when the collision started. Mind you, there are a fair few contenders to sort through. There's the Large and Small Magellanic Clouds. There's the Canis Major Dwarf Galaxy. And then there's the prime suspect, the Sagittarius Dwarf Galaxy, which is believed to have already burst through the Milky Way's galactic disk several times in the past. In fact, like the Large and Small Magellanic Clouds and the Canis Major Dwarf Galaxy, Sagittarius is being slowly absorbed into the Milky Way through a process called galactic cannibalism, the process which allows small galaxies to grow into bigger ones. This is SpaceTime. Still to come, the Mars 2020 rover officially named Perseverance. And later in the science report, we look at the fatality risk factors for the COVID-19 Chinese coronavirus. All that and much more still to come on SpaceTime. NASA's Mars 2020 rover has been officially named Perseverance. 7th grader Alexander Mather from Lake Braddock Secondary School in Burke, Virginia came up with the name as part of a special NASA Name the Rover essay contest which received more than 28,000 entries from American school kids. Glenn Nagel from NASA's Deep Space Communications Complex in Canberra says there's been a long tradition of getting school kids to name the Mars rovers, going all the way back to 1997 and Sojourner.
So after many years of us just calling it Mars 2020, and after a large competition and coming down to a list of sort of a final 9, finally the NASA has announced that Perseverance will be the name of the next big rover heading off to Mars in the middle of this year.
This is all very reminiscent of Sojourner, which was the first rover on Mars.
Yeah, it's been a tradition over time with NASA to take in suggestions from the public and from the mission team people themselves about what we might call these sort of future rovers. And it forms part of an engagement. If you're just calling it the rover or Mars 2020, it's not very personalised in a way. We try not to anthropomorphise our spacecraft too much, but when people see these... Yeah, you can't help it. When people see these robots with their sort of incredible faces, with their camera eyes and everything else, it's hard to not sort of have a connection to them. So actually giving an official name to a spacecraft is great. And in this particular case, Perseverance, the name was chosen by an 11-year-old boy who'd written an essay to NASA about the idea of our perseverance to explore and that curiosity, carrying on from the Curiosity rover, to continue to learn about Mars. And I think it's actually quite an apt name out of all of the names that were put forward.
That's Glenn Nagel from NASA's Deep Space Communications Complex in Canberra. Now, as mentioned earlier, the 1,043-kilogram Perseverance rover is based on the highly successful Curiosity Mars rover, which is exploring the red planet-scale crater. Like Curiosity, Perseverance will be powered by a multi-mission radioisotope thermoelectric generator rather than solar panels, which, as we saw last year with the Opportunity rover, can get covered in dust after dust storms, losing the ability to power the spacecraft. Perseverance is the size of a compact car. The 6-wheel rover's astrobiology mission includes searching for signs of microbial life on the red planet, as well as studying the Martian climate and geology. It will also collect Martian rocks and soils for future sample return missions and pave the way for human exploration of the red planet in the 2030s. Perseverance is currently undergoing final assembly and checkout at NASA's Kennedy Space Center in Florida. It's slated to launch from Cape Canaveral aboard an Atlas V rocket on July the 17th, arriving at Jezero Crater on Mars on February the 18th, 2021.
When you go to another planet, there's just so much potential for making brand new discoveries.
I'm actually putting something together that's flying to Mars.
One way or another, you're going to be on the ground in 7 minutes. We want it to be there safely.
My name is Heather Bonham, and I'm helping prepare the spacecraft that will fly our next Mars rover to the Martian surface.
My name is Diana Trujillo, and I work with robotic arms to collect samples on Mars.
I'm Al Chen, and I lead the landing team for Mars 2020.
My name is Michelle Tommy-Colizzi.
My name is Mujige Stricker.
My name is Eric Aguilar.
My name is Katie Stack-Morgan,
and I'm helping to protect the next Mars rover.
Mars 2020 will be seeking signs of ancient life in the rock record of Mars.
What we're trying to do is to rove around the surface of this unknown planet,
collect samples,
process the tubes as they come back,
to look for things that we call biosignatures,
so that eventually we can bring those samples back to Earth and determine for the very first time, did life exist on Mars?
But also, where could it be preserved for 4 more billion years for us to find it?
Before the rover actually flies, you have to make sure that everything works properly with the flight software and the hardware.
We hit the atmosphere going, 12, 13,000 miles per hour.
After the journey through space, through the vacuum,
we try to test all of our hardware to the environments that we would see.
So that's where a lot of the testing happens behind me.
We spend lots and lots of hours here testing everything.
It gets put in an oven, it gets put in various chambers and clean rooms. There are hundreds of people that have to come together and build a spacecraft. You kind of have to put those different pieces together and make sure that those pieces all are going to work.
And I feel like such a lucky person to be working on this.
Everything that you're touching and all this hard work that you're putting in the long hours.
20 years, the children will be reading this in their science book.
It feels great.
The rover's extensive scientific payload includes 2 microphones and 23 cameras, including a mass-cam stereoscopic imaging system. There's also an X-ray fluorescent spectrometer to determine the fine-scale elemental composition of Martian surface materials. There's a ground-penetrating radar to image different ground densities, to understand structural layers, buried rocks, meteorites, and detect underground water ice and salty brine, down to around 10 meters below the surface. There's an environmental dynamics analyzer to measure temperature, wind direction and speed, air pressure, relative humidity, radiation, and dust particle size and shape. Also aboard is new experimental technology designed to produce oxygen from Martian atmospheric carbon dioxide. That's all part of a project in support of future human missions, both to support life and to make rocket fuel for the return flight to Earth. There's a SuperCam instrument suite providing imaging, chemical composition analysis, and mineralogy of rocks and regolith from a distance. It's an upgraded version of the ChemCam unit fitted aboard Curiosity, but with 2 lasers and 4 spectrometers that will allow it to remotely identify biosignatures and assess past habitability. There's a high-resolution ultraviolet Raman scanning spectrometer and imager, equipped with an ultraviolet laser to determine fine-scale mineralogy and detect organic compounds. Another first for the Perseverance rover is its onboard 1.8 kilogram solar-powered helicopter drone. Equipped with cameras, it'll be test-flown on the red planet to check flight stability and for its potential to scout for the best driving route for the rover. The drone is expected to fly at least 5 times during its 30-day test period, flying up to 3 minutes each day. You're listening to SpaceTime. Coming up next, the Lagrange mission to provide Earth with an early warning of solar storms. And we look at the last flight for the original SpaceX Dragon. All that and more still to come on SpaceTime. The European Space Agency is planning a new mission designed to provide early warning of geomagnetic storms or space weather events heading towards Earth. The Lagrange spacecraft will be positioned in a gravitational well 60 degrees ahead of Earth as it orbits around the Sun. This orbital perch will allow Lagrange to detect potentially hazardous space weather events before they come into view from Earth, thereby giving scientists advanced knowledge of their speed, direction, and the chance of impact. Space weather is a sudden flood of energy and ionized particles such as protons, electrons, and atomic nuclei triggered by powerful eruptions of solar flares and coronal mass ejections on the surface of the Sun. Solar flares are explosions of energy caused by the sudden snapping of tangled and twisted magnetic field lines, known as flux ropes, emanating from sunspots on the solar surface. Sunspots are cooler regions on the Sun's surface that appear darker than surrounding areas because of the magnetic field lines reaching out into space from deep inside the Sun. That prevents some of the heat from within the Sun reaching the surface at that point. Because the Sun's not a solid object but a big ball of plasma, different latitudes of the Sun rotate at different rates, and this causes the magnetic field lines to become tangled and twisted. Eventually it gets so bad they snap and realign through magnetic reconnection. This produces a massive eruption of electromagnetic energy called a solar flare, which, if facing the Earth, can reach our planet in less than 8.3 minutes. Now, if the solar flares are powerful enough, they'll also drag up and eject billions of tons of coronal plasma and embedded magnetic field, frozen in flux, exploding out from the Sun at speeds of up to 3,000 kilometers per second, which, if facing the Earth, could reach our planet in just 15 to 18 hours. And when these geomagnetic storms reach the Earth, the flux of ionized particles slams into the planet's magnetic field, the magnetosphere, and are then guided by the Earth's magnetic field lines through the ionosphere, a region already filled with charged particles, and towards the north and south magnetic poles. As these charged streams of plasma travel through the Earth's upper atmosphere, they collide with oxygen and nitrogen atoms and molecules, causing them to excite and emit photons, giving off a glow and producing colourful curtain-like displays known as the northern and southern lights, the aurora borealis and aurora australis. The colours being emitted depend on which particles are being ionized. Reddish brown glows are caused by the collision of particles with single oxygen atoms in the Earth's upper atmosphere, usually above 300 kilometres. Lower down there's a more greenish hue, created by single oxygen atoms down to altitudes of around 100 kilometres. The kaleidoscopic curtain then turns a whitish-yellow beige when nitrogen's mixed in with the oxygen. Now, aurora can also exhibit a blue, red or even purple glow in the lower atmosphere caused by the excitation of molecular nitrogen below 100 kilometres. However, as well as the spectacular auroral light shows, there's also a dark side to these highly charged particles. They can damage or even destroy spacecraft by shorting out electronics and destroying onboard circuitry. They also cause the atmosphere to expand and contract, increasing atmospheric drag on orbiting spacecraft, resulting in premature orbital decay and the need to use more fuel in order to maintain an operational orbit. Worse still, space weather increases the level of radiation exposure astronauts experience, affecting their health. Meanwhile, on Earth's surface, solar storms can overload power lines, causing widespread blackouts. In fact, in 1989, one such geomagnetic storm blew out dozens of transformers, causing massive blackouts across most of eastern North America. Space weather also affects communications and navigation systems, and it forces polar airline flights to be rerouted to lower altitudes, using up more fuel. By being able to warn of upcoming space weather events, the Lagrange spacecraft will help scientists and the Earth prepare for such events before they happen. The Lagrange spacecraft is named after the 18th century Italian-French mathematician Joseph Louis Lagrange, who was working on the general three-body problem in orbital mechanics when he discovered a series of gravitational wells. These are points in space where the pull of two bodies, such as, say, the Earth and the Sun or the Earth and the Moon, tend to cancel each other out, while at the same time equaling the centripetal force needed for a small object to move relative to the two larger bodies, and so allowing a smaller object to remain in position relative to the other two bodies for extended periods of time. There are 5 Lagrange points, known as L1, 2, 3, 4 and 5. L1, 2 and 3 are along a straight line connecting the two bodies, say the Earth and the Sun. So the L1 position is between the Earth and the Sun. It's often used by spacecraft needing an uninterrupted view of the Sun, such as the Solar and Heliospheric Observatory spacecraft SOHO. The L2 position is on the opposite side of the Earth to the Sun, and it's home to the Planck spacecraft and the soon-to-be-launched James Webb Space Telescope because it's ideal for astronomy, as spacecraft are still close enough to communicate with the Earth easily, and they can keep the Sun, Earth and Moon behind the spacecraft for solar power while still providing a clear deep space view for telescopes. The L3 position is on the opposite side of the Sun to the Earth. Because L3 is always hidden from Earth by the Sun, it's become popular in science fiction as the location for a hypothetical second Earth. The L4 and L5 positions provide stable orbits around 60 degrees ahead and behind the Earth along the Earth's orbital track around the Sun. These are where Trojan asteroids are commonly found, and it's the L5 position where the Lagrange spacecraft will be positioned to monitor the Sun for space weather events. This report from ESA TV.
Our Sun is an enormous ball of hot gas and plasma, 4.6 billion years old. Unpredictable and often grumpy, the Sun emits intense radiation throughout our solar system and blasts colossal amounts of energetic material in every direction, creating the ever-changing conditions in space known as space weather. Solar flares emit electromagnetic radiation and can throw streams of energetic particles towards Earth, while enormous coronal mass ejections fling billions of tons of matter into space at speeds reaching 3,000 kilometers per second. Reaching Earth, these can trigger severe magnetic storms. The energetic particles from the Sun are the origin of our stunning aurora, but they are potentially damaging to vital satellites in space. Geomagnetic storms triggered by their arrival can damage infrastructure on ground. We could lose navigation services from GPS and Galileo satellites, or suffer extended loss of power if grids are overloaded. A single large geomagnetic storm could create billions of euros worth of damage in Europe alone. The European Space Agency, ESA, is building a network that brings together European space weather expertise so that data on solar activity can be collected, shared, and used to issue forecasts and provide space weather warning services. ESA is planning a new mission, Lagrange, which, together with space weather detectors on other satellites, will keep continuous watch over the Sun and provide early warning of potentially harmful activity. The Lagrange spacecraft will have a unique side view of the Sun, enabling it to observe solar active regions, sources of flares, mass ejections and high-speed solar wind streams before they rotate into view from Earth. This will give advanced knowledge of any emerging solar storms and enable more precise estimates of the speed and direction of any incoming coronal mass ejections, The kind of actionable information that we need today.
SpaceX has launched its 20th and final Dragon cargo ship in its original configuration to the International Space Station. All future missions will now use the company's new upgraded Cargo Dragon 2 capsules. The mission, CRS-20, was launched aboard a Falcon 9 rocket from Space Launch Complex 40 at the Cape Canaveral Air Force Station in Florida. The flight also marked the 50th successful landing of a Falcon 9 rocket.
Dragon is in startup. LD, go for launch.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And liftoff of the Falcon 9 rocket and Cargo Dragon on the final flight of the Dragon 1 spacecraft, taking research designed to improve life on Earth and lead discovery in space.
The vehicle begins pitching downrange to get into its proper ascent for orbit. The Falcon 9 is looking good. 2 million pounds of thrust as it goes into space. Coming up in just a few seconds, it will experience its maximum amount of force on the rocket. That'll happen at 1 minute and 18 seconds.
Falcon 9 is supersonic.
Going faster than the speed of sound.
And about to reach maximum aerodynamic pressure.
Vehicle is experiencing maximum dynamic pressure.
You heard the call?
So far, looking great.
It's a beautiful launch. Now, there will be a rapid succession of events coming up in just a bit. We'll have the first stage, main engine cutoff. It'll be followed by a separation, and then that second stage will start. And that'll all happen within a matter of 10 seconds or so of those Merlin D engines getting ready to shut off. And there they go.
Stage separation confirmed.
All right, the first stage is loose, and it is now falling back to Earth. The second stage, engine has started.
Another 210,000 pounds of thrust, propelling Dragon into orbit.
So far, everything with regards to this flight is looking nominal, which means it's performing as expected.
And again, the booster is headed back towards Cape Canaveral Air Force Station, where they are going to attempt to land this booster at landing zone 1 here. That first stage entry burn begins in about 3 minutes now for that booster.
Vehicle is on a nominal trajectory. Acquisition of signal in Bermuda.
So we were really watching closely, listening closely to the weather reports tonight, but so far, all things nominal.
Yeah, it had no problem with the winds down on the ground, lifted off right through there, and no issues at all. The first stage conducted its burn, and now that first stage is falling back to Earth, and the second stage is carrying Dragon onwards to get into that orbit to meet up with the International Space Station. Coming up, we'll get the first stage entry burn will begin. This burn will allow it to slow down the booster and get it into position so that it can land.
If they do this landing successfully, it will be the 50th landing of a SpaceX booster, that's a big number.
They've gotten really consistent at being able to land these boosters. But it'll be interesting because we know we've got 20 to 25 mile per hour winds. Elon Musk, CEO of SpaceX, tweeting it'll be the greatest winds that this booster has faced. So it'll be interesting to see what happens. Dragon is expected to rendezvous with the International Space Station right around Monday evening.
And this will be the 19th time they've landed a booster back on land. The rest of those landings have been on their drone ship, one of their 2 drone ships out at sea. So again, really hoping they're able to do that even with the winds going on. And we should have that first stage entry burn beginning any moment now.
And for those who are gathered locally, make sure you keep an ear out for the double sonic boom when the booster comes back and breaks the speed of sound. That entry burn has begun. The grid fins are out for the first stage booster, and down it comes.
Stage 1 entry burn shut down.
And so they shut down that entry burn. Everything looking great so far.
Coming up in just about 15 seconds, we have our landing burn. Falcon 9 takes a series of 3 burns to do that landing. First is the boost back burn and the entry burn to reduce the aerodynamic loads on the vehicle. Now is coming up on the entry burn. It looks like we have good ignition. This only lights up the center Merlin engine. And shortly after, the 4 landing legs will deploy. Falcon 9 as it's coming back towards landing zone 1. Keep an eye out here for landing leg deploy. I'm hearing a lot of cheers behind me. There's It sounds like we may have touched down. Beautiful. And that is confirmation. That is the 50th successful landing of a Falcon 9 first stage. Congratulations to the entire SpaceX team. Now, real quick here, the second stage is going to have shutdown of its MVAC engine. So there's the call out SECO there. Expecting a call out on the nets shortly. And shortly after, the guidance team will let us know if the second stage. And there's that call out for the nominal orbit insertion. So that means that we're ready for the next step, which is deployment of Dragon from the top of the second stage. Now, once Dragon deploys from the second stage, Dragon carries two types of cargo, pressurized and unpressurized cargo. Unpressurized cargo in the trunk portion and pressurized within the capsule. So shortly here, we should have Dragon deploy. We'll hear that on the launch nets.
Acquisition of signal Newfoundland.
Dragon is carrying about...
Separation confirmed.
There is Dragon gently floating away. People behind me are ecstatic to see this final Dragon 1 spacecraft heading off to the International Space Station.
2 days after the launch, the CRS-20 Dragon capsule was successfully grappled by the space station's robotic arm and maneuvered onto the Harmony module's Earth-facing port. It'll be one of the last times the station's robotic arm will have to perform that maneuver, as the cargo Dragon 2 capsules, like their Crew Dragon 2 counterparts, will have automatic docking systems. The CRS-20 Dragon is carrying 2 tons of supplies and equipment, including the new European Space Agency Bartolomeo Science Facility, which will be installed on the outside of the orbiting outpost European Space Agency Columbus Science Module. Bartolomeo will offer new scientific opportunities both for commercial and institutional users, providing unobstructed views both towards the Earth and out into deep space. Potential applications include Earth observation, robotics, material sciences, and astrophysics. Dragon also carried organ chips for use in new human intestinal studies, looking at the effects of microgravity and other space-related stress factors, as well as experiments looking to see if pluripotent stem cells can be grown into human heart cells. Dragon slated to remain docked to the space station until April 9, when the spacecraft will return to Earth with completed scientific experiments and equipment. And time now for a brief look at some of the other stories making news in science this week with the Science Report. The World Health Organization has formally declared the COVID-19 China coronavirus a pandemic. The deadly virus, which began in the horrific live meat markets of China's Wuhan province, has continued to spread globally in a fast, uncontrolled manner, infecting hundreds of thousands of people in more than 120 countries, with around 5,000 fatalities so far recorded. The World Health Organization is now listing the mortality rate from the COVID-19 virus at 3.4%. Researchers in Wuhan who are working with hospitalized patients from COVID-19 suggest that old age, showing signs of sepsis, and having blood clotting issues are the key factors associated with a higher risk of mortality. But the study, reported in the Lancet Medical Journal, is observational and therefore cannot prove cause and effect, but researchers say it's a good start to finding out who are most at risk. A new study says that women who go through the change before they reach their 40s are more likely to experience multiple health problems by the time they reach their 60s. The findings, reported in the Journal of Human Reproduction, are based on studies of more than 5,000 women. Researchers found around 7 in 10 women with premature menopause had developed 2 or more health problems by the age of 60, compared with around 5 in 10 of the women who experienced menopause at the age of 50 or 51. The health problems include diabetes, heart disease, stroke, arthritis, and breast cancer. Now, the authors stress the study does not show that premature menopause causes these conditions, only that there appears to be an association. A new study warns that social media and smartphone use may be contributing to the rising burden of mental stress among youth. The findings, reported in the Canadian Medical Association Journal, are based on a review of several longitudinal, randomized and controlled studies looking at evidence suggesting an association between excessive smartphone and social media use with mental distress and suicide among adolescents. The authors say most existing data are observational, making causality difficult to establish. Scientists say that 2 especially tenacious species of bacteria, which have colonized the portable water dispenser aboard the International Space Station, are no more dangerous than closely related strains on Earth. The findings, reported in the journal PLOS One, are based on periodic sampling showing the bacteria Burkholderia cepacia and Burkholderia contaminus were contaminating the orbiting outpost's drinking water. These microbes can cause opportunistic lung infections in people with underlying health conditions, and are very difficult to kill using common sterilization techniques. In fact, the bacteria have persisted in the water dispenser despite periodic flushing with an extra-strength iodine cleaning solution. Scientists believe the bacteria were present in the water dispenser when it left Earth. Scientists have observed a new state of matter at the interface between two oxide materials, lanthanum aluminate and strontium titanate. The discovery, reported in the journal Science, showed that electrons combine together in a similar way to how quarks combine to form protons and neutrons. The study's lead author, Professor Jeremy Levy from the University of Pittsburgh, says normally electrons in semiconductors or metals move and scatter and eventually drift in one direction if you apply a voltage. But in ballistic conductors, the electrons are moving more like cars on a highway without giving off heat, and therefore could be used in ways quite different to ordinary electronics. The discovery shows that when electrons can be made to attract one another, they can form bunches of 2s, 3s, 4s, and even 5s that quite literally behave like new types of particles, creating new forms of electronic matter. The discovery is being seen as a major advancement towards the next stage of quantum physics. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free twice-weekly podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.